In January 2025, a Chinese AI startup did something that sent shockwaves through Silicon Valley. They released an AI reasoning model that matched OpenAI's best, achieving 97.3% accuracy on advanced math benchmarks. The catch? They claim to have done it for a fraction of the cost. Within days, Nvidia's stock plummeted nearly $600 billion in the largest single-day drop in US market history. The model is called DeepSeek R1. But here's what makes this story complicated. When the US government actually tested it, they found something very different from the headlines. This is the story of DeepSeek R1, what it actually achieved, where it falls short, and what it means for the future of AI. To understand why DeepSeek R1 matters, you need to understand what made it different. Most AI models learn to reason by studying millions of human examples. Researchers show the model how humans solve problems step by step, and the model learns to imitate that process. DeepSeek took a different approach. They created a version called R10, trained purely through reinforcement learning, with no human examples at all. The model started with just 15.6% accuracy on competition math problems. Then something remarkable happened. After thousands of training steps, the model taught itself to reason. Its accuracy jumps to 71%, matching OpenAI's earlier reasoning models. The researchers documented what they called an aha moment, where the model spontaneously learned to stop, reconsider its approach, and try a different strategy. This was the first open research proving that reasoning abilities can emerge purely from reinforcement learning without any human demonstrations. The final DeepSeek R1 model combined this reinforcement learning approach with some supervised training to fix readability issues. The results were impressive. On the AIME 2024, one of the hardest high school math competitions in America, DeepSeek R1 scored 79.8%. That's slightly higher than OpenAI's O1 at 79.2%. On the Math 500 benchmark, it achieved 97.3% accuracy, essentially matching OpenAI's best. And on Codeforces, a competitive programming platform, it reached the 96th percentile, placing it at expert level among human programmers. DeepSeek also released 6 smaller distilled versions of the model, ranging from 1.5 billion to 70 billion parameters. The 32 billion parameter version alone outperformed OpenAI's O1 Mini on several benchmarks. Now let's talk about what really shook the industry: the cost. DeepSeek reported that the final training run for their V3 base model cost approximately $5.6 million. Compare that to estimates of hundreds of millions spent by US labs on similar models. But here's an important caveat that often gets lost in the headlines. That 5.6 million figure only covers the final training run. It excludes all the prior research, failed experiments, and architectural development. DeepSeek's own paper states this explicitly. Still, their API pricing is dramatically lower. DeepSeek charges about 55 cents per million input tokens, compared to OpenAI's $15 for O1. That's roughly 95% cheaper. This efficiency comes from their mixture of experts architecture, where only 37 billion of the model's 671 billion parameters activate for any given task. In September 2025, the US government released its own evaluation of DeepSeek. NIST, the National Institute of Standards and Technology, tested 3 DeepSeek models against 4 US models, including OpenAI's GPT-5 and Anthropic's Opus 4. The findings painted a more complex picture than the headline suggested. On software engineering and cybersecurity tasks, US models significantly outperformed DeepSeek, solving 20 to 80% more tasks. But the security findings were even striking. When researchers tested jailbreaking attacks, DeepSeek's most secure model complied with 94% of malicious requests. US models, just 8%. In agent hijacking tests, where attackers try to redirect an AI assistant to steal data or send phishing emails, DeepSeek models were 12 times more likely to follow malicious instructions than US frontier models. The report concluded that while DeepSeek shows competitive math and reasoning abilities, its security vulnerabilities and censorship patterns may pose risks to users and national security. Beyond security, researchers have documented systematic censorship built into DeepSeek models. Professor Emilio Ferrara at USC led a study that tested DeepSeek with 646 politically sensitive prompts. What they found was subtle but significant. DeepSeek uses chain of thought reasoning, meaning it shows its thinking process before giving an answer. The researchers discovered that sensitive content would often appear in the model's internal reasoning, but then be removed or rephrased in the final output. Topics like government accountability, transparency, and civic mobilization were systematically suppressed. Meanwhile, language aligned with state narratives was occasionally amplified. The NIST evaluation confirmed this pattern, finding that DeepSeek models echoed 4 times as many inaccurate and misleading narratives aligned with Chinese government positions compared to US models. This censorship is built directly into the model weights, meaning it persists even when running the model locally outside of China's servers. Despite these concerns, DeepSeek's release has had an undeniable impact on the AI landscape. Downloads of DeepSeek models have increased nearly 1,000% since January 2025. Academic researchers have embraced the open source release. A team at Stanford created a competing reasoning model called S1 for under $50 in compute costs. Berkeley researchers replicated the core reinforcement learning technique for just $30. Industry leaders took notice. Sam Altman called DeepSeek R1 an impressive model and said it was legit invigorating to have a new competitor. He also admitted that OpenAI may have been on the wrong side of history when it comes to open source. Meta's chief AI scientist, Yann LeCun, argued that DeepSeek's success proves open source models can match or exceed proprietary ones. The release has fundamentally changed the conversation about what's possible with limited resources. So, what's the real takeaway from DeepSeek R1? The model represents a genuine technical achievement. The pure reinforcement learning approach to developing reasoning is a significant contribution to AI research. But the government evaluation makes clear that US models still lead in security, safety, and practical software engineering tasks. The gap in math and reasoning benchmarks has narrowed, perhaps more than anyone expected. What happens next will depend on whether the open source community can address the security and censorship issues and whether the efficiency gains DeepSeek demonstrated can be replicated by other labs. One thing is certain, the AI race just got a lot more interesting. If you found this breakdown helpful, subscribe to the channel for more deep dives into AI infrastructure and technology explained.